Good evening, ma'am. My name is Mayan ESTOMAGO, and I will be answering and explaining my answer from all the different topics we've discussed in this subject. So, I'll be starting with trigonometric function. So, my given is y equals sec theta tan theta. As we can see here, we can't simplify it further. So, we'll be using the product rule, which is f times g. So our f is sec theta and our g is tan theta. So we have to derive our f and g. So the derivative of f is sec theta tan theta and the derivative of g is sec squared theta. So we'll have to simplify our equation further. So we'll have y prime equals sec theta times sec squared theta plus tan theta times sec theta plus tan theta. So as we can see here, we can factor out our sec thetas to simplify it further. So we'll have y prime equals sec theta times sec squared theta plus tan squared theta, and this will be our final answer. Next will be the inverse trigonometric function. So our given is y equals inverse tan x. So for any inverse function, will represent an angle. So we'll have let theta equals inverse tan x. So I can apply the original tangent in both sides because our main goal is to find d theta over dx. So we'll have let tan theta equals tan times inverse tan x. So we'll cancel out, we'll cancel both the tan and the tan inverse tan x. So we'll arrange it a bit. So we have d over dx times tan theta equals x. So theta is the function of x. So we'll use the chain rule. So the derivative of tan theta is sec squared theta times d theta over dx equals 1 because x is 1. So we'll arrange it a bit again. So we have d theta over dx equals 1 over sec squared theta. So I've mentioned in the beginning that theta is equals to inverse tangent x. So we have 1 over sec squared inverse tangent x. So we can simplify this further by breaking down this equation into algebraic expression. So we'll have d theta over dx equals 1 over 1 plus x squared. And this will be our final answer. Next will be the natural logarithm set A. So the given is y equals t times of a natural log t squared. So we'll be using the product rule. So y prime equals d over dt of t times of the natural log t squared plus t times d over dt of a natural log t squared. So the derivative of natural log t squared will be 2 times 1 over t. So y prime equals 1 times natural log of t squared plus t times 2 times 1 over t of a natural log t squared. So we'll cancel t and 1 over t. So our final answer will be y prime equals natural log of t squared plus t plus 2 natural log t. And this will be our final answer. Next will be set B of the natural logarithm. So we have the given ln times cosecant x minus cotangent x. So instead of this given, I will change it into negative ln times cosecant x plus cotangent x. So we copy the negative ln, and we all know that cosecant x is 1 over sine x plus cotangent x is cosine x minus sine over sine x. So in order for us to remove the negative part of the ln, we'll change it into negative 1 and put it in the exponent part of the inner equation. So we'll have ln times 1 plus cotangent x over sine x to the power of negative 1. So in order for us to remove this negative 1, we can flip the equation over. So we'll have ln times sine x over 1 plus cosine x. And we're not done yet, so we'll have ln times sine x over 1 plus cosine x, and then plus 1 minus cosine x over 1 minus cosine x. So we can think this 1 plus cosine x is a plus b, and this 1 minus cosine x is a minus b. So we'll have 1 minus cosine squared x. So 1 minus cosine squared x is equals to sine squared x. So we'll have the equation of ln times sine x times 1 minus cosine x over sine squared x. And we can cancel this sine x and this, and we'll have sine x in the bottom part. So we'll have 1 over sine x is cosecant x, and cosine x over sine x is cotangent x. So this will be the final answer. Next is exponential function. So our given is e to the power of 2x equals sine times x plus 3y. So we can take the natural log of both sides. So we have ln e to the power of 2x equals ln sine times x plus 3y, or 2x equals ln sine times x plus 3y. Then we can take the derivatives. So we'll have 2 equals 1 over sine times x plus 3y times cosine times x plus 3y times 3 times dy over dx. So we'll arrange it. So we'll have dy over dx equals 2 times sine times x plus 3y over 3 times cosine plus times x plus 3y. So we can simplify this further. So we'll have 2 tangent times x plus 3y over 3. So this will be the final answer. Next will be the inverse logarithm. So our given is y equals log base 2 of 50. So in order to solve this, we put y prime equals 1 over 50 of a natural log of 2, and we cannot simplify it further. So our final answer is this.